Hi. Okay, we're going to refilm this section because my children were crazy in the last video. So we're just going to start from scratch, friends. Use the following information and the diagram to determine which lines, if any, are parallel. If so, justify your conclusion. If not, put not enough information. So in my class, we said anytime you are proving lines parallel, we say boom, parallel. Anytime you're doing that, you need a converse theorem. So there were 5 theorems we learned about. If the lines are parallel, there are 5 things that are true. So let's go back to those 5 things. If the lines are parallel, you know that corresponding angles must be congruent. If the lines are parallel, you know that alternate interior angles must be congruent. If the lines are parallel, you know alternate exterior angles must be congruent. If the lines are parallel, you know that the same side interior must be supplementary. And if the lines are parallel, you know that same side exterior must also be supplementary. So that's if the lines are parallel. If A is parallel to B, and these 5 things exist. Well, what is the converse? The converse says if any of these 5 exist, so in my class we did some hand motions with this where we rained our hands down. If any of these 5 are true, for any one set, then boom, you know the lines are parallel. And so we have to use the converse theorem, okay? And so we're going to look at this group, and I'm going to start with the diagram because I do not love the way I clipped this picture. I apologize. This is my fault. If you're watching this, I take full responsibility. I did not do a great job cropping this. So that's supposed to be line A. That's supposed to be line B. This is supposed to be line T. This is supposed to be line U. And these lines intersect at 4 points. Around this one point, there are 4 angles, 1, 2, 5, and 6. Around this one point, there are 4 angles, 3, 4, 7, and 8. Around this one point, we have 9, 10, 13, and 14. And then around this one point of intersection, we have 11, 15, 12, and 16. And so here's what we're going to do. We're going to see if the information gives us, that is given, if it gives us enough information to say that there's a set of lines that is parallel, we're going to give it. We're going to give a reason, so it should be a converse. If it doesn't fit one of these 5, we are going to say not enough information. So they both look parallel, just looking at this diagram. A looks parallel to B, T looks parallel to U, but we have to give a mathematical reason or a theorem that is true. So what happens if 13 is supplementary to 14? So let's zoom in. If 13 is supplementary to 14, now y'all, the first thing I notice is that those are from the same group. That isn't even touching 2 sets of possible parallel lines. We just have the intersection of 2 lines around one group of 4. Y'all, we know that those are always going to be a linear pair. 13 and 14 adding up to 180 is always going to be true, regardless of if the lines are parallel or not. And so that is going to be a not enough information. Those are always going to be supplementary because those are a linear pair. Okay, not enough information because those are a linear pair. And notice that linear pair is not one of my reasons that lines can be parallel. Okay? All right, what about if 2 and 13 are congruent? So here's 2, here's 13. Now these are from 2 different groups. So what is the transversal that is going through 2 and 13? That is going to be T. What set of lines get intersected, or what pair of lines get intersected by 2 and 13? A and B. So A and B are going to be parallel. Why can we say that A and B are parallel? Well, because 2 is out here on the top right, 13 is down here on the bottom left, so that is going to be our converse theorem of what kind of angles? Those are alternate exterior. So converse of alternate exterior angles theorem, which says that if a single set of alternate exterior angles are congruent, then boom, we know that the lines are parallel. So let me erase this. I've got to fix this update about changing back to the eraser every time. So if you know how to fix that, please let me know. I just need to Google it. All right, so 11 is supplementary to 10. So here's 11 from this group. Here's 10 from this group. Well, what is the bow and arrow, or what is the transversal that touches both of those? That is going to be B. What lines get intersected? That is going to be T and U. So what kind of angles are those? Those are same side interior. We know that those should be supplementary. And so these lines, T and U, are going to be parallel. So T, change to pen, T is going to be parallel to U. Why? Because of the converse of same side interior angles theorem, which says that if those are supplementary, then boom, those pink lines must be parallel. All right, so I'm going to erase again. And then now we have 6 and 9 being congruent. So I'm going to start fresh. New mercies every morning. 6 and 9. Okay, so here we go. Starting fresh with this picture. 6 and 9. It says that they're congruent. What is the transversal that touches both of those? T is the transversal. What are my possible parallel lines? A and B. And you just have to ask yourself, is that relationship, 6 and 9, is that going to be one of my 5? So 6 and 9, those are alternate interior, which is one of my 5. So I'm going to say that A is parallel to B because of the converse, CONV, of alternate exterior angles theorem. Because those alternate exterior angles are congruent, then we know that those lines must be parallel. All right, next problem is number 23. And it says, what if 13 is congruent to 15? So here's 13, here's 15. What kind of angles are those? If B is my transversal, then my parallel lines are going to be T and U. So I'm going to say that T is parallel to U. Why? Because those are corresponding angles. Those sit in the bottom right-hand corner, so the converse of the corresponding angles theorem. Corresponding angles say, hey, this is the bottom right, this is the bottom right, and so those are congruent, and if those are congruent, then boom, I know that those lines are parallel. So I'm looking at these different groups every single time. All right, last but not least, what if 12 is supplementary to 3? So where's 12? 12 is here. Where's 3? 3 is here. Now, y'all, this one's tricky because where is my transversal? It's right here at U. Where are my possible lines, A and B? When you first go through this group of 5, it does not fit any of these scripts immediately. 3 is the top left on the exterior. 12 is the top right on the interior. So the only option is corresponding, but those are not in the same corner. Top left and top right are not the same. But I want you to remember that if 12 is supplementary to 3, then we know that 12 and 15 are congruent. So if 12 and 15 are congruent, we can use substitution to say that if 3 and 12 add up to 180, then because of vertical angles, then 3 and 15 add up to 180. What kind of angles are 3 and 15 when I'm looking at this? 3 and 15 are going to be same side exterior. So what we're going to say is that A is parallel to B. But first, you have to say vertical angles. Vertical angles says that 12 is congruent to 15. And then we can use by substitution 3 and 15. So angle 3 and angle 15 are same side exterior angles. So by the converse of same side exterior angles theorem, if 3 and 15 add up to 180, then boom, A must be parallel to B. So that's the most complicated one because we had to use vertical angles first.